Hello everyone, this is Science Professor Bennett. The objective today is to complete energy transformation writing project. And with the task, students will read the article Energy Transformations. Students will also write at least 3 paragraphs explaining energy transformations using the article and background knowledge as sources of information. So this is the article. It's a very short article that talks about energy transformation as we can see in the image. This is also the article. The first paragraphs, it says, define or explain the term energy and provide an example to show. And you need to answer all these bullet points for the first paragraph. This is the second paragraph. You discuss the sun as the major source of energy on earth and explain why solar energy is considered inexhaustible. Paragraph 3 and the concluding paragraph, you analyze the law of the conservation of energy. So let's look at paragraph 1. Define or explain the term energy and provide an example to show a person if a person has energy. And in our discussion, we said that energy is the ability to cause things to move or to change. Energy is also the ability to do it. So if a person has energy, they will be able to lift up this weight. They will be able to change the position of this ball. Because remember, energy is the ability to cause things to change. The next bullet point, it says, distinguish between kinetic and potential energy as the two main forms of energy. Energy exists either as kinetic or potential energy. Kinetic energy is the energy of motion, and potential energy is the energy due to relative position. So that's the difference between kinetic energy and potential energy. And potential energy depends on the height, relative position, or elevation. Potential energy also depends on the mass. The greater the mass, the greater the potential energy. The greater the height or the relative position, the greater the potential energy. Let's go back to the bullet point. And the next one says, examine the factors that affect kinetic energy and illustrate with example. Then you are going to describe the general relationship between mass, speed, and kinetic energy. So when we go to kinetic energy, it's the energy of motion. If a person is moving, they possess kinetic energy. Here we are looking at the factors that affect kinetic energy. And we know that as we increase the speed, kinetic energy increase. Also, the more mass a moving object has, the greater is the kinetic energy. So the general relationship is that as you increase the mass and the speed of an object, the kinetic energy also increases. The next bullet point, it says, examine factors that affect potential energy and illustrate with examples. So you need to provide examples. When you are examining the factors that affect potential energy, you need to provide examples to support these factors. Then you are going to also describe the general relationship between mass, height, relative position or elevation, and kinetic energy. This means that as you increase the height, the mass or relative position, how does that affect the potential energy? So let's look at potential energy and the factors that affect potential energy. So the first one is, you need to remember that potential energy is the energy due to relative position. If you look at these 3 basketballs, which one has the greatest potential energy? Ball 1, because it's at a higher point or higher elevation. Potential energy is also affected by mass. The greater the mass, the greater the potential energy. So with the example, you can talk about having 3 balls at different heights, and because ball 1 is at a higher elevation or height or position, Ball 1 will have greater potential energy. All right? And also, you can talk about two objects at the same height having different masses. The one which has the greater mass will have the greater potential energy. So paragraph 1, we are done with paragraph 1. Paragraph 1, very easy. We've done with all the bullet points for paragraph 1. And now we are going to move to paragraph 2. And paragraph 2 says, discuss the sun as the major source of energy on Earth and explain why solar energy is considered as inexhaustible form of energy. And the sun is a major source of energy on Earth. The energy from the sun is also called solar energy. And solar energy is considered as inexhaustible. Inexhaustible means it's unlimited. You cannot use all of it. The sun is out almost every day. So it's in abundance. So that's why we say energy from the sun or solar energy is inexhaustible. Okay? That's the first bullet point. That's why solar energy is considered inexhaustible source of energy. The next one is say distinguish between radiant energy, electric energy, sound energy, and thermal energy. Explain why these forms of energy are examples of kinetic energy. The next bullet point is a differentiate between chemical energy, elastic energy, nuclear energy, and gravitational energy. Explain why these forms of energy fall under potential energy. So let's go to the forms of energy. Radiant energy is the energy carried by light. The sun produces light energy and heat energy. Radiant energy falls under kinetic energy because light travels, light moves. The next is heat energy. Heat energy or thermal energy is the energy that comes from heat. The hotter an object, the more thermal energy it has. And this is also kinetic energy because heat moves. If you turn on the heat at one point of the room, within a short time, you will feel the heat energy in other parts of the room. The next form of energy is electric energy. It's the energy carried by electric current. Example, lightning, electric charges moving through a wire. This also falls under kinetic energy because electric energy, as the energy flowing through wires, it moves. And that's why we're able to turn on light. The next one is nuclear energy. Nuclear energy is energy stored in the nucleus, and this one falls under potential energy because it's a stored energy. The next is gravitational energy. It's a form of potential energy associated with gravity or gravitational force. It's the energy held by an object when it's in a higher position compared to a lower position. Okay, so this energy is also potential energy because this energy is the energy due to relative position. The higher the object, the greater the gravitational position when you are talking about the Earth. The higher you are above the surface of the Earth, the greater the potential energy. The next one is elastic energy. Elastic energy is a form of potential energy that is stored in an elastic object such as a coil spring or a stretched elastic band. This energy also falls under potential energy. The next is chemical energy. It's the energy stored in chemical bonds. Food contains chemical energy. The flame of a candle is the result of chemical energy stored in the wax. So the wax contains chemical energy. The atoms and molecules, they contain chemical energy. So chemical energy is stored energy and it falls under potential energy. So food, the energy inside the molecules of an atom, they are the energy stored in molecules and atoms, they all fall under potential energy. The next is sound energy. Sound energy is energy transferred by vibrational waves. So sound energy is kinetic energy because sound travels, sound moves. The final paragraph, third paragraph, you are going to analyze the law of conservation of energy. All right? So the law of conservation of energy states that energy is never created nor destroyed, but energy can change from one form to another. An example, we see that chemical bond energy stored in food can be used to power muscles to cause movement. All right? So from chemical bond energy to kinetic energy. And that's the law of the conservation of energy. So that means we are transferring the chemical bond energy into kinetic energy. Energy is being transformed, but you are not creating it. The other example is turning on light. You are changing the electric energy to light energy, to radiant energy. So you are not creating the radiant energy. You are changing the form of energy from electric energy into light energy. And the next bullet point, it says cite evidence or details from the article that connect or support the law of conservation of energy, and explain in your own words. So you can state the law of conservation of energy, which is stated in the article. The law of conservation of energy, it says that, if you read the article, it says, paragraph 2, it says, the law of conservation of energy says that energy is neither created nor destroyed. Okay? So you can state this law, you can put it in quotation, then you explain in your own words what this law means. Okay? Then we go to the next, in paragraph 3, it says, distinguish between renewable energy sources, non-renewable energy sources, and alternative energy sources, and provide examples for each. Then when you are done, you are going to restate the important point that build and reinforce the text as a whole. Then finally, you highlight the significant importance of the main points. So you are writing your conclusion. So let's go to distinguishing between renewable and non-renewable energy resources, and we are done with the project. So when we talk about renewable energy resources, they are energy sources or resources that are replenished continually. Example, solar energy, wind energy. They are constantly always available. They are replenished continually. When we talk about a photovoltaic, solar panel is an example of a photovoltaic. A photovoltaic is a device that transforms radiant energy directly into electric energy. And we have biomass. Biomass is renewable energy from plants and animals. These are renewable because plants and animals, they are available, okay? For example, solar energy is renewable because they are available continually, okay? As long as we have plants and animals available, then we'll be able to produce the biomass. So biomass is a renewable energy from plants and animals. Then we move to non-renewable energy resources. Non-renewable energy resources, they are used faster than they are replenished. So we use them faster than they are being replaced. Example, nuclear energy, fossil fuel. Examples include crude oil, coal, and natural gas. Fossil fuels, they are combustible energy resources formed from decayed plants and animals in the earth crust over millions of years. They take a long time, millions of years, for it to be formed. And that's why we say they are renewable. They are non-renewable because they are used faster than they are being replenished. Example, coal, natural gas, crude, gasoline, diesel, heavy oils. Fossil fuels, they cause pollution, as we can see in the image. Okay? And the example of non-renewable energy resources, they include nuclear energy. And this is the energy contained in atomic nucleus. Example, the nuclear fission and nuclear fusion. Okay, the sun generates its energy by nuclear fusion of hydrogen nuclide into helium. Okay, we have fusion. Fusion means you are joining smaller nuclei together, and fission means you are splitting this nuclei. And in all these processes, tremendous amount of energy is being produced. Finally, we go to alternative energy resources. Alternative energy resources, they are alternative to fossil fuel, and they are safer, cleaner, and cause less harm to the environment. Example is solar energy, wind energy, hydro energy. This is hydro energy. This diagram also shows hydro energy. Okay, so the energy to move these turbines, they come from flowing water. And the last one is geothermal energy. Geothermal energy is heat energy from the ground. All right, so we have covered everything in the project. Okay, so this has been Science Professor Obene, and thank you for watching.